Let us solve a question on degree of homogeneous function. The question is, consider the utility function u is equal to under root x cube plus y cube. Which of the following statements is true? First statement is u is not homogeneous function. Second is u is homogeneous of degree 1. Third option is u is homogeneous of degree 3. And fourth option is u is homogeneous function of degree 3 upon 2. We need to find out which of the following statement is correct. Okay, so let's come first about the homogeneity. Okay, we say, let us say we have a function. Let us say we have a function u is equal to f of xy. Okay, this function is called homogeneous. This function is homogeneous. If I increase both x and y by same amount, rather if I increase x and y by a factor, let us say lambda. Let us say if f of lambda x comma lambda y, and if it is equal to lambda raised power n times the original function f of xy, then I say that the given function is, this function is homogeneous of degree n. Okay, let me give you an example. Let us say I have a function. Let us say I have a function f of xy is equal to x times y. This is our function. Now, to find out whether this function is homogeneous or not, what will we do? We increase both x and y by a factor lambda. That is, let us write f of lambda x comma lambda y. That means in place of x we have lambda, and in place of y we have lambda y. Okay, so what will we get here? So lambda into lambda is lambda square times xy, and we know x into y. X into y is our original function. Can we write it like this? Lambda square times the original function. So in this case we say this function is homogeneous of degree 2. Okay, if we are able to factor out lambda from both the variables, then we say it is homogeneous of degree 2. Let us take another example where a function is not homogeneous. Let us say we have a function f of x comma y is equal to x square plus y. Okay, now to see whether this function is homogeneous or not, let us increase both x and y by a factor lambda. So lambda x y is increased by the same factor, that is lambda. So what will we get in the place of x? So we have lambda x square plus lambda y. So we will get here lambda square x plus lambda y. So let's take one lambda common. So lambda, we are left with lambda x plus y. Here you can see we are not able to get the original function here, because original function is, so here we have square, sorry. So we get lambda times lambda x square plus y, but this is not our original function. Original function is x square plus y. If we are not able to take or get lambda outside from both the variables like in the given example, then this is not obviously the homogeneous function. Okay, so this is a case of a function which is not homogeneous. Okay, because we are not able to factor out lambda completely, and we should have got lambda times the ordinal function, but we are not getting the ordinal function. So this is not obviously the homogeneous function. Okay, so its example, how do we use it? Let us take an example. Let us say we take a production function. Let us say Q is equal to, output is a function of labor and capital, and let me explain it like this. Let us say we have a function L plus K. This is our production function. Now if I take if I increase both, let us say labor by increase by a factor 2 and capital also by 2, so we have 2k. Let us see what happens here. So in place of L we have, so this 2 denotes our lambda, so we have 2L plus 2k. So here what will we get? You can see we are able to take 2 common and we are left with L plus k. Okay, so which is equal to 2 times the original function, that is Lk. So clearly this function is homogeneous. To find out the homogeneity of what degree, so in place of 2, if I write here lambda, so let us write it here lambda. So what happens here, you can see, so I get here lambda. Okay, so this function is homogeneous of degree 1 because we have lambda raised power 1 is equal to lambda. So this function is homogeneous of degree 1. That means if I increase both the inputs, okay, if I double the both inputs, our output will also get doubled. Okay, so this is the case of homogeneous function. Now let's come to the question. So we have, and let me write it here, u is this very stuff. Let us increase both. Let us say u is a function of f of x, y, which is equal to under root x cube plus y cube. Clearly this function, as we will see, it is homogeneous. Let us increase both x and y by factor lambda. So we have lambda x comma lambda y should be equal to, we have lambda x whole cube plus lambda y whole cube. Okay, so can we write it like this, lambda cube x cube plus lambda cube y cube, we can write. So which is equal to under root of, let's take lambda cube common, we are left with x cube plus y cube, and can we write this function? So we have f of lambda x comma lambda y came out to be, let us take lambda cube, can we write it like this, under root lambda cube times under root x cube plus y cube. We can factor this out. So lambda cube means, under root of lambda cube means 1 upon 2 here, so times x cube plus y cube under root, it is our original function, that is f of x, y. So here you can see this becomes, if I write it here, so we get lambda raised power 3 upon 2 times the original function. So this function is homogeneous of degree 3 upon 2.